Hello, 7th grade, and this is lesson 7-3 on two-step equations with fractions and decimals. In tonight's lesson, you're going to be able to solve two-step equations with fractions, and you're also going to be able to solve two-step equations with decimals. And I have to say, you probably knew this was coming. I mean, come on, we just solved two-step equations with whole numbers, so of course we have to go to fractions and decimals. All right, now normally, or in the past, we've had this sort of problem. 4/3 times x is the same as 12. And to solve this, well, instead of dividing by a fraction, which doesn't make much sense, 12 divided by 4/3, a lot of the times we multiplied by the reciprocal and did 3/4. And then we're left with x is equal to, well, 12 over 1 times 3/4, which is 36/4, which is the same as 9. So that's how we solved them in the past. And that's okay. So we can do that same idea here. However, this time they added in a -7. So we have 3/4 times p minus 7 is 11. And when we solve two-step equations with fractions, we do them really in the same way. We first get rid of that -7 by adding 7. We undid it. And we're left with 3/4 times p is equal to, well, 11 plus 7 is 18. And again, we can multiply by the reciprocal of 4/3, because again, you'd get 12 over 12, which is just 1. So we're left with 1p. And do that to both sides, of course. All right, and I'm going to simplify before I multiply. Let's see, 18 and 3 are across from each other, and 3 goes into both. So I'm left with 24 over 1, which is just 24. There we go. And look at that, I have two problems for you to do now. We have -7/10 times k plus 14 is -21. And then for b, we have 2/3 m minus 4 is 3. What I'd like you to do is go ahead and do these problems, and when you're all done, go ahead and check your answer. All right, so go ahead and pause me now. All right, and here are the answers. I just wrote them up there while it was paused. So A, you can see how I subtracted 14 from both sides, and this got more negative. Two negatives, it gets further away from 0. So that should be -35, and in the end, I did some multiplication, and I ended up with k is equal to -50 over -1, because again, the -35 and the -7. So two negatives make a +50. And for b, again, I got rid of that -4 by adding 4, and I was left with 2/3 m is equal to 7, or 7 over 1, since I knew I was going to multiply by a fraction. Then I multiplied by the reciprocal of 2/3, which was with m. So each side got multiplied by 3/2, and I was left with m is 21/2, or 10.5. All right. Now, it's fine if you choose to solve problems that way. However, when we start getting 2 or more fractions, sometimes it's just nice to get rid of them. That way you don't have to deal with them when you add or subtract and deal with mixed numbers. So this is a prime example of that. I have 1/2 times y plus 3 is equal to 2/3. And what I want to do is just get rid of the fractions altogether. And how I do that is I look at what's in the denominators. And I'm going to outline them in blue. I have a 2 and I have a 3. And I need to think, what's a multiple of both 2 and 3? And what comes to mind automatically is 6. All right, 6 is a multiple of both 2 and 3. So what you do is you take that multiple and you multiply everything by it. So that'll get multiplied by 6, this will get multiplied by 6, and this will get multiplied by 6. Because what ends up happening is, well, 1/2 times 6, well, 2 goes into both of them, and I'm left with 1 times 3, which is 3y. Well, here I just have a 3 times 6, so that turns into 18. And I have equals, another fraction, so I take a look, 2/3 times 6. Well, let's see, 3 goes into both of those. So I'm left with really 2 times 2, which is 4. Well, now I have really a problem that we were dealing with before. I have a nice, easy two-step problem. I subtract 18, and I'm left with 3y is equal to -14, divide by 3, and y is -14/3, or -4 2/3. Either one of those would work. So let's try that again, because I know it can be a little strange. So we're going to do A together, and then I'm going to let you do B. So A, we have 2/5 times x plus 2 is equal to 3/4. Again, to get rid of those fractions, I see first what's in the denominator. I have a 5 and a 4. Well, multiple of both of those is 20. So everything's going to get multiplied by 20. Okay, and you have to make sure you do it to everything, because if you don't, then your equation is no longer balanced. We've talked before, you can do anything you really want to an equation, just as long as you do it to both sides, so that way they remain equal. So here I have 2/5 times 20. Well, if I do that, again, if you put that in your calculator, 2/5 times 20, you're going to get it as well. But I take a look, well, 5 and 20 share 5. So 20 divided by 5 is 4, so I'm left with 2 times 4 is 8x, plus 2 times 20 is 40, is equal to, well, 4 and 20 share 4, so 5 is left over there. 3 times 5 is 15. I subtract 40, and I'm left with 8x is equal to 25, a negative 25. 40 is bigger, so it'd be negative. So I divide it by 8, and I'm left with x is equal to negative 25/8, or 3 1/8. Negative 3 1/8. All right, so now it's your turn. I would like you to try to solve B, and when you're all done, come back and check your answer. So I have negative 7/12 plus y is the same as 1/6. So again, take a look at your denominators, find a common denominator, and go from there. So go ahead and solve this now. All right, let's check this one, shall we? Well, looking at it, 12 and 6 both share 12, so I'm going to times everything by 12. And here I'd end up with a negative 7, because those cross out, plus 12y is equal to 2. So add 7 to both sides. 12y is equal to 9 divided by 12. And I get y is equal to 9/12, which simplifies, because 3 goes into both of them, to 3/4. Y is equal to 3/4. All right, whoops, too far. All right, final problem of the night is with decimals. And really, the whole idea of multiplying each thing like we did before, or just got done doing, we could get rid of fractions. If you really wanted to, you could get rid of decimals in the same way, but you don't have to. So here's this one. Suppose your cell phone bill is $30 a month plus 5 cents per minute. Your bill is $36.75. Use the equation 30 plus 5/100 times x is equal to $36.75 to find the number of minutes on your bill. I'm going to solve this in 2 manners for you. That way you can see what you like. The first way is just solving it as it is written. Right? And the way we do that is, well, we'd undo any addition or subtraction, so I get rid of that 30. And I'm left with 5/100 x is equal to $6.75. So we just got rid of the payment, that $30 a month you just paid to have your cell phone on. And you found out that you paid $6.75 with your phone calls, because it costs you 5 cents per minute. So let's see how many minutes you actually talked by dividing it by that 5/100. And if you use a calculator to divide it out, or however you choose to do it, you end up with 135. So you were talking on your phone for 135 minutes. Right? That's the one way you can solve it. And there's nothing wrong with it. If it works for you, it works for me. Another way is to get rid of those decimals. And how you do that is you take a look and see what's your biggest decimal. What is the place value to? And, well, we have 2 decimals here, and they're both to the hundredths. So because it's to the hundredth place, we're going to times everything by, surprise, surprise, 100. And again, everything, even that 30, even though it doesn't have a decimal, you have to do it to everything. So if I do that, 30 times 100 is 3,000. Here, this turns into a 5x. Oh, not plus, that's equal. And that's going to equal 36.75, because again, it's multiplied by 100. And all this does is take away those decimals. So if you don't like dealing with decimals, you can get rid of them in this way. And I end up with 5x is equal to 675. Well, again, you divide by 5, and you end up with 135 minutes. So you can choose which way you prefer to solve them, if you just want to deal with decimals or if you want to get rid of them. Either way, as you see, you get the same answer. But that's tonight's lesson. We talked about how you can solve two-step equations when there's fractions or decimals involved. You have a good night, and I will see you tomorrow.